Hello everyone, hope you all are doing well. So in today's video we are going to solve our blind series 34th question, which is to find the number of connected components in a graph. So let's read the problem statement. So we are given an n, which indicates the total number of nodes in an undirected graph from 1 to n, and another integer e, which indicates the total number of edges in the graph, and we need to calculate the total number of connected components in that graph. A connected component is a set of vertices in a graph that are linked to each other by a path. So let's see what actually are connected components. So if we see this graph, it is a disconnected graph. And why I'm saying it's a disconnected graph, because if we consider these two components, this one and this one, so if I say from vertex 1 I can reach to vertex 0 and vertex 2, and yeah, I can reach, but also I can't reach from vertex 1 to vertex 3, because there is no such path exists for me to reach from vertex 1 to vertex 3. Although these vertex are of the same graph, but there's no path, either direct or indirect path exists to reach to vertex 3. That's why I'm saying this is a disconnected graph. And the components you are seeing here, these connected components are actually what we need to find, this and this. And although if a vertex is alone with no edges in it, either in degree or out degree, we still consider this single vertex as an independent connected component. So that's what we need to find in the question. So let's see how can we do that. Well, we can solve this particular problem by using the DFS algorithm. And how can we do that? We will consider every single vertex in the graph. And if the particular vertex is unvisited, which we haven't visited it any once, so we will consider that particular vertex as a source of a new created connected component. And we will start exploring it using DFS. And that particular, after exploring it to the end, that particular component that we have found will become our first component. Okay, and then and like this we will start exploring another unvisited vertex. And if any case, if we find a particular vertex is visited, so we simply skip it, because we already know that that particular vertex which has already been visited is a part of a uh, previously connected component that we have found. So we will not further explore it, because we know that that particular visited vertex is already a part of a component. So that's how we will solve this problem. And if you want to know how DFS works, so you can see my previous video to know about the DFS approach. I have explained in that one. So let's move to the coding part and see further how actually we will design an algorithm to find our connected components. Okay, so input contains two integers n and e, and then the next line contains two integer u and v, which are connected in undirected fashion. So let's first take n and e. Okay, so next line will contain the source and the destination. Okay, will be e times. So we'll create a loop which run tells e times. Okay, and then we will have u and v. Okay, and v. Okay, so let me create adjacency list. And I will insert in this adjacency list. Okay, okay, v. And before that, since the nodes are starting from 1 to n, so I will increment the u and v, so that it will become a zero indexed. It will, or basically start from 0 to n minus 1. So it will just use the free space of the zeroth index. Okay, so push back u. Okay, so I have created the adjacency list. Okay, So now I will run the DFS on each of the vertex. So before that, I will create a visited array of boolean of which is of n size, and all the value will be false initially. And now I will run the DFS for each of the vertex. Okay, if it is not visited, if the current vertex is not visited, so I will run the DFS for it. I will send the adjacency list, I will send the visited array, I will send the current node. Okay, and so I will create a result. The result will count the number of connected components I have come across so far. So if a particular node is not visited, so I will increment the result counter. Okay, so I will increment the result. Okay, and at last I will print the result. And now I will write this DFS function. Okay, I will get the adjacency list, then I will get the boolean array of the visited or the visited array, and at last the node, the current source node. Okay, so first of all I will visit that particular node. Okay, so I'll mark it as true. Then I will start exploring its neighbors. Okay, and if any of the neighbor is not visited, okay, so I will visit it and run the DFS for that particular neighbor. So that's all the code. So let's try to run it. We're getting 6 Okay, so the 6 error is because I have not given the size of this adjacency list. So the size of this adjacency list is based on the number of vertices. So the number of vertices is n. So I will give it a size of n. So now I will try to run it. Okay, so it's the sample test case is passed. So let's try to submit the code. Okay, so every test case is passed. Okay, so that's all for today. You will find the question and the source code link in the description, and I will meet you on the next video.